2 kg of sample P and 1 kg of sample Q are heated over the same heater for 8 minutes. Okay guys, same heater for 8 minutes. Okay, that means the power is the same and the time is the same also at 8 minutes. So the amount of energy supplied Q is the same for both P and Q. This part clear? Okay, and the graph shows the temperature changes for sample P and Q. So which statement is correct? So guys, you see, we know that the thermal energy supplied is the same. Okay, I can write it as Q for both, and the mass P is 2 kg, Q is 1 kg. I know the differences. Okay, and for the temperature change, right? P is 10 to 40, 30 degrees Celsius. Whereas for Q, right, is 10 to 30, is 20 degrees Celsius change. Okay, so what I can do is that I can draw something like a table. Okay, so this is my P, this is my Q. Okay, so in terms of the energy that is absorbed, okay, both will be Q. Okay, so guys, Q is to Q. Okay, if I do it something like a ratio, right, I get 1 is to 1. Okay. Okay, then after that I have the mass. Okay, for P the mass is 2 kg. Okay, and the mass for Q is 1 kg. So the ratio is also 2 is to 1. Okay, so now if I want to find the ratio of the specific heat capacity, okay, sorry, I still have the change in temperature. Okay, so for P the change in temperature is 10 to 40, 30 degrees Celsius. Okay, and then for Q it is 20. Okay, so if I want, I can also change this to 3 is to 2. Okay, and lastly, guys, if I have all this ratio, the ratio of the thermal energy, mass, and the change in temperature, I can find the ratio of their specific heat capacity. Okay, how? I just need to take Q over mass over the change in temperature. So in this case, I can just take 1 over 2, 1 divided by 2 divided by 3. Okay, so it's 1 over 2 times 3, and the other side it will be also 1 over 1 times 2. So I have 1 over 6 is to 1 over 2. If you change it to the simplest form, right, okay, you will get the answer as 3. Sorry, you will get the ratio as 1 is to 3. Okay, guys, this one you just use your calculator. You can get the ratio very easily. So we know that the specific capacity of Q is 3 times that of P. Okay, then if you look at the option, of course, C is the answer. Okay, and guys, you see, A, B, C talks about the specific capacity, but D talks about the heat capacity. Are we able to find the ratio of the heat capacity? Actually, we can, no? Okay, we just take Q divided by the change in temperature. So it's just 1 over 3 is to 1 over 2, and the ratio it will become 2 is to 1 for heat capacity. So it, of course, it's not equal because it's not 1 is to 1. Okay, this part, okay?